Our last presentation will be with regards to digital humanities work that's being done with XSEDE. To do that, we'll have Sandeep Satheesan presenting along with Michael Simeone from Arizona State University. Thanks.
Oh, yeah, got it, yeah. Hi, good afternoon, everyone. Welcome to the final presentation on this section. So we'll be talking about some of the digital humanities projects that I was involved with, and Michael Simeone and others also involved with, especially with an XSEDE project, XSEDE realm. And we'll get started with an outline of the presentation. Basically, we'll have introduction to digital humanities provided by Michael Simeone, and then we'll visit some of the XSEDE projects and how Clowder was used, what was the contribution of those projects to Clowder, and some of the feature requests that those projects have towards Clowder. Michael.
Wait. I won't start talking until I'm near the microphone. Okay. Now I'm officially talking. Hi, everybody. I'm Michael Simeone. I'm from Arizona State University. I work in a research lab which is located in our library and is charged with interdisciplinary data science. So our whole role is to try to stitch together research computing, the library, and faculty research all into one place, and that helps explain some of the weird stuff that we do sometimes. One of the things that we engage with is digital humanities. How many people have heard of this term digital humanities before? All right, anybody want to take a shot at defining it? Because I sure don't want to define it. So it's actually a pretty contested term in the sense that it's been around fairly recently, but there have literally been volumes about debates in the digital humanities, and many of those debates are definitional. I think for the purposes of research computing and interdisciplinary computing, the humanities are an interesting frontier, but it's not always an intuitive fit. So large amounts of campuses in terms of the distribution of students and faculty commit a lot of work and research to liberal arts disciplines, but a lot of times when it comes to arts and humanities, it can sometimes be tough. I think when we're thinking about many of these things that I have up on this slide are intersectional with a lot of stuff that we do already in research computing. They're just not always explicitly represented in data or as computational processes in what we do. I think it's becoming more and more of a norm, right? And many of you are already doing that kind of work. I think one of the biggest problems that I think we face, especially with one of the projects that we'll be talking about here, is that oftentimes one of the biggest challenges is identifying what part of the problem can be computable. So if you're looking at somebody, here's a great example, right? We're trying to look at the concept of habitability, right? So digital humanities is a broad enough definition where somebody may be a digital humanities scholar if they're studying algorithms that determine habitability, but don't write or use any algorithms that talk about habitability. We could talk about people who do a study of the dashboards from astrobiology that people use to think about habitability, or we might be doing natural language processing of thousands of scientific articles trying to understand what that term habitability has come to mean over the last 50 years in the published scientific record. So it's a pretty broad definition. And depending on what kind of scholar you're talking to or trying to collaborate with, then identifying what part of the problem can be computed, right? Research computing is more interested in applications. And so trying to knock off a chip of that problem wherein it can be computed is oftentimes one of the most difficult things. Humanities bring complexity and eschew reductionism. Oftentimes it can feel reductive to folks if we want to take a piece of their problem and compute it. One of the reasons that I think Clowder and the whole idea of staging data can be very powerful is that oftentimes, especially early on, when people try to, say, quantify things like literary genre or style, or even want to make broader historical arguments about large corpora of text documents or image archives, The critique is that these are too reductive. Oftentimes that means people are recommending that we do not do computing on questions of cultural import. I recommend always that the answer is actually more computing, because if you don't like a model or you feel like one model is too reductive, then we ought not shut down all modeling. We should make more models and compare them, or see what they perform or see what they teach us. And so that multiplicity is important. Folks in the humanities, and I know this is not news for many people, don't see the world as made of data. A lot of times in science, sometimes, even if we don't believe that's our like deep down model of the universe, is that everything is made of information. In the humanities, it's especially the case that we don't believe that material reality is reducible to data. That introduces a number of different challenges to doing computing. But thinking about data as a theory, right, or a hypothesis is not necessarily controversial in science. It's especially, it's a little bit more charismatic to the humanities, which kind of resist a certain kind of reductionism. When doing this kind of work, staging is a really great way to think about this, because what you do with your data is temporary and an experiment, and you can always go back and restage it. And so it's a particularly valuable thing to highlight when working in something like Clowder, where sharing and publishing are very intuitive to folks who work in the humanities and do research, but this idea of staging allows a certain kind of flexibility, which many people find to be really valuable. And then I'll skip this next part because I know we have limited time here. Wait, I think, oh yeah, the last thing I'll mention is that Sandeep is going to be talking about a project about image analysis, which is its own kind of difficult beast of a challenge. But then there's a most recent project that I'm working on at Arizona State University with my collaborator Sean Walker in social science, where we're looking at fake news in social media, which is a pretty broad category, but we're interested primarily in creating a high-resolution archive of these things. Back to the idea of images and complexity of messages. It's hard to identify what actually happened in a social media interaction if we don't understand the images and other kinds of accessory media that were circulated with the social media objects themselves. So if we don't go and get the full text of the linked news, if we don't get right, that's a very important thing to collect, especially given the attrition rate of some of the most critical communications and conversations that people are dealing with things like dis and misinformation. If a third of all the media is disappearing within a year, then it's imperative to create a high-resolution archive. And so what we're doing here is, I see in some ways as an extension of what Sandeep will be talking about, which is trying to consider a rich set of questions of text and images together, creating an archive where we can make that happen, but without some of these understandings and environments to compute images or consider them alongside other kinds of analysis, we don't have anything. So thanks, and I'll turn it back over to Sandeep. Thank you.
So basically going forward, we'll start with the first project that I will be mentioning. This is a video analysis Tableau. Basically this dealt with like studying video data. As you can see, and I think Dan Harwood, you mentioned one of your presentation, the data, about like 80% of data, like overall internet data, is consisting of videos, and I think like in your case it was images. So the challenge itself is like huge, and this project was involved in creating tools that would help researchers to analyze video data, especially movie data and things like that. That basically it was an attempt at fusing software, arts, and humanities. You can find more details of the project itself. Virginia Kunj, she was the PI on the project, and this is actually an instance of Clowder at that time. The screenshot from a few years ago when VAT used Clowder. So this is the basic data flow, how it looks like. So when a video file gets uploaded, a few extractors process the video file. So you can see a short identification extractor. Then there is a LSV extractor, which basically extracts different features of each of those shots that were identified. And there is also a video preview extractor that creates a preview that can be displayed on the web. And also there is like a movie slice extractor, which creates like a barcode-like visualization of the video. And this is the architecture. Like again, we use Clowder, to process all these messages, which will be processed by all these different extractors. We also developed a batch extractor for this in order to. So since these videos are like larger, sometimes it takes like a long time to process these videos. So we create like a batch extractor which would submit an HPC job. I think we use Gordon XSEDE resource at that point to submit a job to the HPC resource, which would process the files there. And this is an example of the shot detection extractor. Basically, this is a computer vision extractor which identifies shots in a movie, in a video. Basically, it looks at differences between the frames, and if there is like a significant enough difference, it identifies as a key frame of the new shot. And all these shots are created at the same time. What we also do is like we compare these shots with the already existing shots in the system, and then you can get this nice similar URL here. When you click on that, what Clowder does is it goes through all the shots in the system and then makes this comparison and like come up with the shots that are similar to the queried shot, as you can see in this one. Again, that's based on like different parameters, like digital cosine transform, grayscale. So it might not be like visually similar, but like at some level they are similar when you look at those features. This is the movie slice extractor that I was talking about. So basically, the idea is to arrange these individual frames of the video in a way like a cube, and then like take a slice out of it, and it forms like a barcode-like visualization here. It allows the researchers to study the movies, the videos, their forms, irrespective of their narrative elements, and also this can also be considered as like a unique a barcode, which can later be used to uniquely identify a video itself. And then the shot indexing that I mentioned, like each of the shots that get created, in each of the shots, we kind of like run all these different algorithms, calculate feature score, and then which is used later in the comparison step. So this is something that we contributed back to Clowder during the project, basically creating this extractor, which would just create these batch jobs within a compute resource. So initially they were all like running as like dedicated resources, but then we had this batch extractor that was created. When a file gets submitted, it would fire a job. It would create a job in the HPC queue, and then when the job picked up by the system, and when the file is processed, it will then submit all the metadata back to Clowder. So that way you don't have to like really wait for. I mean, you have to wait, but if the files are large enough, it would mean to use such compute-intensive resources. So these are again like some screenshots of the system of the Clowder instance. You can see the video preview. You can also see the movie slice visualization and the similar shots that were identified. Or the shots of this video, and there like you can also find similar shots later on. So these were some of the major contributions to Clowder. I think I joined the VAT project probably on the second half of the project itself. So some of the contributions had already taken place before that itself, in terms of like the file sections that you see in Clowder, and feature-based comparisons that I mentioned, and also the processing files as HPC jobs. I was involved in that. Some of the feature requests that came through the duration of the project is like intelligent load balancing between small and big jobs. So how do you make sure that this is a small enough file that it can be processed right away, or this is a large enough file that it needs to go into the HPC resource, and doing that in some sort of an intelligent fashion, and letting the user know that this is what's going to happen. And then again, combining multiple files into like a single HPC job. We were basically doing like one job per file, which is not an efficient way of doing it. But if we also, I think, another request is to combine some of the resources into one job and then submit there. Similarly, improving the image-based retrieval of shots. Like the algorithm itself was complicated, and it took a lot of time to calculate these scores. And I think some improvement over there would really help. Let me quickly move on to, this is the team, and this is one of the recent presentations, the paper from the project team. Let me quickly move on to the next project, which also had like significant contributions to the IR, to the Clowder. This deals with, deals with studying the farm security administration, black and white and color photographs, mostly from the Depression era. And I'll go quickly to the contributions. It basically used the advanced search feature a lot in terms of like coming up with these complex queries to study the data set. And also this one feature, which is still under development, is basically to promote extracted metadata fields, to say that this particular metadata field is more important for this domain, and admin can say that this is, and then it shows up on the search page more at the top. I think probably in the interest of time, I'll skip the yeah, the request again, like here, were to like improve the algorithms, and in terms of like providing different user interfaces, like changes, for example, like grid view for search results and those kind of things. Yeah, this is the team, and this is a recent paper from the team on the project. I think I'll stop here, and if there are any questions, I can take. Okay.
Thanks, Sandeep. Thanks, Michael.
Thank you.